Hi everyone, and welcome to the last section of Chapter 1, which is about properties of real numbers. And in this video, we're going to talk about what exactly is a real number. So first, we want to recall that we have different kinds of numbers. Earlier, we talked about the set of the natural numbers, or the counting numbers, which includes numbers 1, 2, 3, 4, and so on. As an aside, if you wanted to be really posh, you could refer to this collection using this strange looking N for natural. If we expand our universe a little bit and allow for the number 0, we end up with a set of whole numbers. And that is denoted with a W. And then including the opposites of all the natural numbers, so -1, -2, -3, and so on, we come up with a set of integers. And the set of integers is represented not by an I, but with a fancy looking Z, or a Zinteger. And then finally, we talked about the set of all rational numbers, which is the set of all fractions where both the numerator and denominator are integers. And the notation for this collection is a fancy Q for quotients. And we should note that by design, the set of all rational numbers includes these other sets. Integers are rational numbers because you could write -3 as -3/1. And that's a fraction where both the numerator and denominator are integers. So integers are rational, whole numbers are rational, natural numbers are rational. But a number like 2/3, for example, is not an integer. So it doesn't go both ways. And these four sets really encompass a lot of the numbers that we know and love. But it turns out that we haven't accounted for all of them. So there's another collection of numbers called the irrational numbers, which by its name is in opposition to the rational numbers. So an irrational number is a number which cannot be written as a ratio of two integers. In other words, an irrational number is one that is not rational, which is not so surprising given the name. It's not so easy to figure out that a number is irrational. But there are some examples that you can kind of keep in your head. Square root of 2, that is the number that when squared gives me 2. Everybody's favorite constant pi. And then we also have Euler's constant E. So these are some common examples of irrational numbers. Now, irrational numbers are also numbers that cannot be written as a decimal with either a finite number of decimal places or an infinitely repeating block of finitely many digits. That sounds kind of confusing, but if we look at the square root of 2, so if we plug it into our calculator, for example, then we get that the square root of 2 is approximately this. This is what's going to show on your calculator, maybe not this many digits. It's not the exact value of square root of 2. It's just an approximation. There is no telling what the digits are after this last 7. Being an irrational number, you're never going to run into a point where you have a huge block of numbers that just repeats. From just looking at this decimal, there would be no way to infer that the number is irrational, because it could be that I just didn't go out enough places to find what my repeating block looks like. So it is kind of difficult to recognize when numbers are not rational. But that's pretty much all of the numbers that we're considering for the time being. So to recap, our universe of numbers goes like this. We start with the natural numbers, 1, 2, 3, 4, and so on, and expand our universe very slightly by throwing in the number 0. And then we expanded our universe a little bit more by adding in all of the negative numbers to consideration, the integers. And from there, we started making fractions with integers. That gave us the rational numbers. And the rational numbers make up a chunk of all the numbers, but it turns out that the irrational numbers, which is completely separate from the rationals, surprise, surprise, makes up an even larger chunk than the rational numbers do. Even though it's so hard to figure out when a number is irrational, there are actually more irrational numbers than rational numbers. The two of these collections together give us what's called the real numbers. To put it into a more formal sentence, a real number is any number that is either a rational number or irrational. For example, square root of 2, 0, negative 500, negative 3.89725119, 119.3, really any number you can think of. Pi, Euler's constant E. So we have integers, we have rational numbers, we have irrational numbers. All of those are under the umbrella of a real number. And that about wraps it up for this video.